Jai Hind everyone, I am Pankaj Kumar. Hope so you all are doing well. This video is regarding the fat metabolism. So as you can see here, that is a fat metabolism will be regarding the how the fat can be metabolized and how we can form a energy from the fat. Or in this video, you'll at the end of this video you'll get to know how we can oxidize the fat. What is the beta oxidation and how it is different from the alpha oxidation, and how many ATP will be generated if the fat will be metabolized of any carbon of the fat will be metabolized. So usually not we are not going to discuss about the unsaturated fatty acid metabolism only. We'll see and uh, we will concentrate it only on the saturated fatty acid metabolism. So let's begin the class. So what is the fatty acid or fatty acid? You can see if I am writing here fatty acid, what does it mean? So fatty acid is something which will have the uh, like hydrocarbons. These are the hydrocarbon chains you can see here. These are the hydrocarbon chains, and one side it is methyl group and another side it will be the COH group. So I took as a 16 carbon compound, that is a palmitoyl acid, and palmitoyl acid will be the or palmitic acid you can say that will be the saturated fatty acid. Now see the next slide. So in this video first we will understand the fatty acid metabolism will be occur in the three steps. So first is the beta oxidation, in which acetyl coenzyme will be formed. Second, the acetyl coenzyme will be entered into the citric acid cycle, and third you will find the whatever the reduced form of the molecules will be formed like NADH or FADH, that will be go to the ETS. Now, so first is here is the beta oxidation. We are going to see the beta oxidation of the saturated fatty acid. Here you will find the double bond formation between the alpha and beta carbon of the fatty acid. First, we have to form a double bond between the alpha and beta carbon in between the fatty acid, and if you'll see, there will be different numbers of the carbon chain will be present. So there is a important enzyme which is called the acyl coenzyme dehydrogenase. So acyl coenzyme A dehydrogenase will be different for the different number of the carbon chain. If the carbon is from the 12 to 18 carbon, the VLCAD, like very long chain acyl dehydrogen coenzyme A dehydrogenase will be act on that, and it will occur this enzyme will only found in the inner mitochondrial membrane. So now any carbon chain between this have to go to the inner mitochondrial membrane. Now if the carbon chain belongs to 4 to 14, then medium chain acetyl coenzyme A dehydrogenase will act on that, and from 4 to 8 carbon chain short chain acetyl coenzyme A dehydrogenase enzyme will act on that, and it will be form the double bond between the alpha and beta carbon. Now important thing is that the MCAD and SCAD having a matrix, this will be present in the matrix of the mitochondria. This is the position of the enzyme. So VLCAD is present in the where inner mitochondrial membrane, and MCAD and SCAD is in the matrix of mitochondria. So fatty acid, suppose this is the fatty acid which is 16 carbon compound like palmitic acid, it is coming inside, and then uh, FLCAD will be what it will do. Okay, how it will come inside? So there will be carnitine shuttle. Okay, there will be carnitine shuttle which will help in the like transport of the fatty acid. Now the fatty acid came into the mitochondrial matrix, and then the VLCAD which is present in the inner mitochondrial membrane, it is converting It is not exactly converting. It is making a double bond between the alpha and beta carbon. So this is a trans double bond. Okay, so here I have to write it the different band. This is FADH. So this is a trans, means what? There will be cis and trans form will be there. So here you will get the double bond in the trans form, and it will form trans 2 acyl coenzyme. What is this? This structure, it is representing the second number of the carbon. There is a double bond into the second number of the carbon. So the second step is the addition of the water. So the addition of the water will be convert the trans 2 acyl coenzyme A into the enoyl coenzyme A hydratase. It will convert into the beta hydroxy coenzyme A by the help of the enzyme of enoyl coenzyme A hydratase. So this enzyme will convert the trans 2 acyl coenzyme A into beta hydroxy coenzyme. So you found here in the first step, you found the FAD as a reduced substrate. So there will be one enzyme which is having the reduction in this. So that enzyme will be that is acyl coenzyme A dehydrogenase. So here you mention one enzyme name, that is acyl coenzyme A dehydrogenase. So where I can write okay, I am writing here the acyl coenzyme A dehydrogenase. So this acyl coenzyme A dehydrogenase will convert the fatty acid into the trans 2 acyl coenzyme A, and in that you will get this important thing, that is the FADH. Now this FADH will go to the ETF. Where it will go? It will go to the ETF, and from there it will transfer to the ETS. So electron transport chain directly it will go. Where it will go? It will go to the direct electron transport chain. So we'll talk about it, but come to the second step. You got the final product as a beta hydroxy coenzyme. Now this beta hydroxy coenzyme A will be converted into beta, will be converted into the beta. So it will be converted into beta ketoacyl coenzyme. Here one NADA plus H plus will reduce into the NADH, and this NADH will go to the complex one. This NADH will go to the complex one. Now in third step, you're done. Which enzyme is helping in that? The beta hydroxyacyl coenzyme. So this you remember it, this enzyme, because it will be helping also in the conversion of the ketone. It will also help in the conversion of the ketone, but there will be one important point when we'll read that topic, ketone formation, then we'll read it. But you remember this enzyme at least for now. Now, so beta ketoacyl coenzyme A will be converted into acetyl coenzyme A by the help of the acyl coenzyme A transferase. This enzyme will also called as a thiolase. Why it is called as a thiolase? This enzyme is called as a thiolase. So it required one coenzyme A. Again, it required for conversion of the beta ketoacyl coenzyme A to acetyl coenzyme A. It required one coenzyme A as well as which will transfer the coenzyme A. Okay, so it have it the acetyl coenzyme A will form. So from 16 carbon compound, how many acetyl coenzyme will form? That will be total 8. That will be total 8. But how many steps it will take? It will take only in 7 steps. Okay. So because if you are breaking the 8 carbon chain like this, 8 carbon chain you are breaking. So until you will break the 8th one, so remaining this will automatically it will convert into the acetyl coenzyme. But there will be one more step we will discuss in the next class. here we are seeing the how many ATP will be required. Now there is a two fate for the acetyl coenzyme A. There is a how many fates? There are two fates for the acetyl coenzyme A, as you know. Uh, Either it can go for the oxidation in the mitochondrial matrix in the citric acid cycle or the Krebs cycle, or it can go for the fatty acid or lipid membrane formation into the cytosol. If it is present in the cytosol, it will go to the fatty acid or lipid membrane formation, or it can go for the oxidation. We want to go to the oxidation pathway. So there was only 16 carbon compound. There was only 16 carbon compound. So in 16 carbon compound, 8 acetyl coenzyme will be formed and in 7 steps. So if you will see 7, it's not like a 7 step. It will better we can say this will be the 7 breakdowns. How many breakdowns will be occur? Total 7 breakdowns will be occur. Okay. So total seven breakdowns will be occur. Okay, fine. 7 steps as a 7 breakdowns. Okay. So these 7 steps will be done, and in each step you are getting, in one step you are getting how much? In one step you are getting one FADH and one NADH. So you have to multiply with the 7. So 7 FADH and 7 NADH. So each FADH will give you 1.5 and ATP, and 7 NADH will give each NADH will give 2.5 ATP. So total how much ATP you will get? It is already written there, 28 ATP. Now if I am asking that this what will be occur with this acetyl coenzyme A? So 8 acetyl coenzyme will enter into the Krebs cycle. Where it will enter? Krebs cycle. Now you have to tell me in one Krebs cycle how many, in one Krebs cycle how many ATP will be formed. Okay. Now you have to tell me the how many in one Krebs cycle of after the complete oxidation. So as you know, in one Krebs cycle there will be two NADH will be formed and one FADH will form and one GTP will form. So altogether, okay, wait, three. So here we can see in Krebs cycle total three NADH will form. How many? Total three NADH will form. Okay, now three NADH and one FADH and one GTP or one ATP will form. So now you have to tell me the how many ATP will form after the complete oxidation of 8 acetyl coenzyme A, or we can say from 16 carbon palmitic acid, how many ATP will be formed altogether. So let's see how many of you are commenting, giving the correct answer. If it will be wrong, I will correct your answer there in the comment, and let's wait for your answer. Thanks for watching till now. We'll meet you in the another video in which we'll see the most interesting things like the ketone formation and how the diabetes will be like become harmful in terms of the ketone formation, and how the what is the relation between the glucose and the fat conversion during the loss of the insulin or in the diabetes. So this we'll see in the next class. For now, we thanks for watching. We'll meet in the next video. Jai Hind.